9.2, our discussion is going to be linear regression and the coefficient of determination. Now, the first thing that we're going to do is look at what is called the least squares line. Now, if you recall from 9.1, we had the scatter diagram. The least squares line would be the equation of a line that would best fit for those 5 points. So that's why it's also called the line of best fit. And we're going to refer this back to the x and the y values that we used in 9.1. So the fish, the length of the fish, and the weight of the fish. So here's the equation for the least squares line. This is called y hat equals a plus bx. B is the slope of the line, and A is the y-intercept, or where it crosses the y-axis. Now, these are the formulas that we're going to be using to find the slope as well as the y-intercept. So you'll see a lot of those summations because, again, we will use that table, which if you'll look, I already have the values down there. So we're going to use the values from that table that we used in 9.1. If you'll notice on the y-intercept, y bar, that is the mean of the y values, and x bar is the mean of the x values. So that's what that is. So if you'll notice, I have that table already in the notes. And if you will recall from 9.1, these are the summations, and those are the values that we will use. Over here to the left, I have y bar and x bar. So we're going to go ahead and calculate those. And to calculate y bar, it's the summation of y. So the summation of y was 53 divided by however many there are, which there's 5 in this case. So 53 divided by 5 is 10.6. And then x bar would be the summation of x, 167, divided by, there are 5 values, and 167 divided by 5 is 33.4. So these two calculated values we will use when we're going to find the y-intercept. But the first thing that we find is the slope. So I'm going to come down here. And the formula for the slope is n, and there are 5 values, so 5 times the summation of xy, and the summation of xy is 2103, minus the summation of x, 167, times the summation of y, 53, and we're going to divide that by n, which again is 5, times the summation of x squared, and the summation of x squared is 6069, minus the summation of x, 167 squared, or to the second power. Now again, the key on putting this into your calculator is making sure that you put parentheses to enclose your numerator as well as your denominator. So when you put all of that into your calculator, get a little bit closer, and push equals, you're going to get 0.67752443. So it would be okay in this example to round this to 2 decimal places, so it would be 0.68. So I'd be okay with that. If you go further than 2 decimal places, it's fine, but minimally in this one, 2 decimal places. Now, the reason we have to calculate the slope first is because if you'll notice in our y-intercept formula, you need b, which is the slope. So we have to calculate the slope first because we need that value when we calculate the y-intercept. So now I'm going to calculate a. And the calculation for A is y bar, and we calculated that to be 10.6, minus B, the slope that we just calculated, 0.68, times X bar, which is 33.4. So 10.6 minus 0.68 times 33.4. And when you put that into your calculator and round it to 2 decimal places, you get negative 12.05. And it's okay to get the negative values. Now, we are now going to create, which is what we are looking for, and on a test you will be asked to find the least squares line. So notice I have an arrow, and I'm going to move it over here so you see the star. Now, the general formula is A plus BX. So what we're looking for is y hat equals A, the y-intercept, we calculated to be negative 12.05, plus B is your slope, 0.68, times x. So this is my ultimate goal right here. Because as we move to the next page, what we're going to do is we are going to use this formula. Now, to find the least squares line or the line of best fit, what you would do, because how do you graph a line? Well, if you have 2 points, you connect them and you have a line. So in order to graph a line, all we need is 2 points. So we're going to pick 2 values for x, and I've done that down here. I've chosen x to be 25 and x to be 40, and I'm going to substitute it into the equation to find the 2 y values. I would then go back to my scatter diagram, plot those points, and draw a line, and that would be my line of best fit, or my least squares line. Now, notice for our problem, I'm using 2 x values that are between 20 and 46. Now, why between 20 and 46? Because 20 was my smallest x value and 46 was my largest x value. So I'm going to choose, that's why I chose these 2 numbers, because they are between them, which makes it easier to plot. So, let me get this lined up. We are going to put 25 in for x. So I'd put negative 12.5, or 12.05, sorry about that, plus 0.68 times, and we chose x to be 25. Now, this is going to create an ordered pair. Our x value is 25, and when I put these values in this least squares line, it's going to give me the calculation for the y value. And what we get is 4.9. So this equals 4.9. So this is 25 inches in length, 4.9 pounds. Now, again, we would plot this point on the scatter diagram. Then we would find this ordered pair. So now we're going to let x be 40. So we would have negative 12.05 plus 0.68 times, now I'm going to use 40 as x, and when I go to my calculator, I get 15.07. So this would mean that a fish is 40 inches in length. It would weigh 15.07 pounds. So then I would go to my scatter diagram, I would plot both of these points, get a ruler out and draw a line, and that's your least squares line. Now, the other thing we use the least squares line for is to make predictions. So if we wanted to predict the weight of the fish, then we could use this least squares line. So there are 2 types of predictions you need to be aware of. One is called interpolation, which means you predict within the range of data. If you recall our x values, the smallest one was 20 and the largest one is 46. So any number in between those would be within, and that would be considered interpolation. So extrapolation is when you're outside of that range. That would be numbers that are smaller than 20 or larger than 46. So let's do 2 examples and see what could occur. So our equation is negative 12.05 plus 0.68x, and now this tells me predict the weight of a fish that is 30 inches long. So we're going to use this formula to predict the weight of a fish that is 30 inches in length. So we would have negative 12.05 plus 0.68 times 30. And so our x value is 30, and we would do this calculation to find our y value, which would be 8.29. So what we've done is we have made the prediction that if I were to catch a fish that is 30 inches in length, I predict it will weigh 8.29 pounds. Now, this prediction is interpolation because 30 is between 20 and 46. Let's look at an example where we do an extrapolation. And this time, we are going to say that the x value is 12. So I'm going to use my same least squares line formula, negative 12.05 plus 0.68 times 12. So you go to your calculator and you do that calculation, and then you go, something doesn't seem quite right. So you calculate it again and you get the same number, and you get negative 3.914. So based upon this information, we're saying that if a fish is 12 inches in length, it will weigh negative 3.914. I don't know about you, but I don't think I've ever caught a fish that weighs negative pounds. That's not possible. So that's why interpolation is good and safe, extrapolation is risky, because sometimes it will not give you a good prediction, such as that example we just did. All right, the last concept that we're going to look at in 9.2 is what is called the coefficient of determination. This is the percent, so it's going to give us a percentage of the change in y, which in our case would be the weight that is due to the change in x. So what's the percentage that because it grows longer, it starts weighing more? So if you had a perfect linear correlation, which we didn't, remember we had 0.996, we had a strong correlation, but it was not perfect. But if you did have a perfect linear correlation, that means that 100% of the change in the weight is due because the fish got longer. That gives you perfect predictions. But most of the time, there are multiple variables that influence the change in y. So the weight of a fish is affected obviously by how long it is, but it could be affected by the food in what it's swimming. I've had students say it could be affected because whether it's pregnant or not. So there are other factors that would go into play as to why a fish weighs more. Now, how do we calculate that? We've already calculated R, so all I have to do is square that number. So the coefficient of determination is R squared. So we calculated R to be 0.996, and I'm going to square that. So 0.996 gives you 0.992016, and we're going to convert that to a percentage, which would give us 99.2%. So what that tells me is, if you'll notice down here, it tells me that 99.2% of the variation of the weight in the fish can be explained by its length, meaning 99.2% of the reason it weighs more is because it's getting longer. So what percentage is unexplained? Well, all you do is take 100% minus 99.2%, so 0.8% is unexplained, and that is 9.2.